Hello and welcome. My name is Sarah Guido, and I will be giving you an intro-level overview to machine learning with scikit-learn. So a little bit about me. I'm currently a master's student at the University of Michigan School of Information, where I'm studying information analysis and retrieval, which is basically a fancy way of saying data science. I also work part-time as a data analyst for the HathiTrust Digital Library, where I'm currently analyzing server log data and trying to make predictions about unauthorized usage of HathiTrust materials. I'm also the lead organizer of the Ann Arbor PyLadies chapter. So in my talk today, I'll talk about some basic machine learning concepts, as well as give an introduction to scikit-learn syntax. I'll talk about supervised and unsupervised learning and give an in-depth example of each of those. And then I'll finish with the importance of data preprocessing, validation and testing, and some good strategies for machine learning. So what is machine learning? Machine learning is the application of algorithms that learn from examples. It exists at the intersection of artificial intelligence, statistics, and computer engineering. It's based on the idea of representation and generalization, the representation of relationships within the data, and the ability to generalize those relationships to data that the model hasn't seen. This means that we can create a model that will take in data and learn from it, and we can apply what it learns to other data. So why should we care about this? Whether you know it or not, machine learning is everywhere. When you receive a funky-looking email, usually your email filter will automatically classify it as spam. If a spam email slips through to your inbox and you manually mark it as spam, your filter learns from that input and will mark similar emails as spam in the future. Or, the more movies you rate on Netflix, the better that the Netflix recommender system will be able to show you movies that you actually want to watch. Machine learning is especially useful in data analysis. It can help us determine which features are useful, predict labels on both categorical and continuous data, and help us figure out if any patterns exist at all. So here's some important machine learning terms that I'll use throughout my presentation. So when I say instance or data instance, I'm referring to a piece of the data. This is the data that our algorithms will learn from. So, for example, the data collected from the email itself in our spam email example would be an example of an instance. So features are what describe those instances. So with our spam example, a feature could be the frequency of capital letters in the email, or it could be the number of words that match known spam words. A class is the representation of those relationships between the instances and the features. So a class could be a label, like spam or not spam.